Welcome back to the GCSE Maths Pro YouTube channel. In this video, we will be going through the second part of proportion, which is inverse proportion. If you haven't already seen the video on direct proportion, it will be linked in the description, so make sure you check that one out first. So just to recap, as we saw in the previous video, these are the two formulas that you need to memorize in order to work out direct or inverse proportion. So we already went through the first formula for direct proportion, which is y is equal to kx. And now in this video, we're going to be focusing mostly on the second formula, which is for inverse proportion. So I've used y and x here just as an example. They might use different letters in the question, that's fine. As long as you substitute in the letters in the order that you see them written in the proportion relationship, then it's fine. So you can see here I've got y is inversely proportional to x. So the y goes first in the formula and then the x comes afterwards. Inverse proportion is where we have, let's say that the value of y is increasing, the value of x would be decreasing, or vice versa. They're going in different directions. It's inverse. K, as we said in the previous video as well, just represents a constant, which is, in other words, a number. Now, that value will change for every single proportion relationship. You just have to work it out in the question, which we will obviously go through. So the formula is y is equal to k over x. Be really careful here that you don't put the fraction the wrong way around, because it can be quite easy to think that it's x over k, but it's not. The constant or the number is in the numerator and then x is in the denominator. So other than that, the steps to working out inverse proportion and direct proportion are exactly the same. We're just changing the formula to start with. So as we saw with our direct proportion video, we started off with the format of having a table. They might lay it out like this. So this is our first example. We are told that y is inversely proportional to x. Then we have to complete the table. You can see there are two missing values, one for x, one for y, and then we do actually have a pair of values for both. This video is going to be quite repetitive in terms of the steps. It's exactly the same as direct proportion. We're just using a different formula. So our step one is the same. We want to write down the correct formula, so inverse proportion, and we have got y and x, so I can carry on by using the same formula that we just saw, y is equal to k over x. That's the correct formula this time. Step 2, you will always be given what I like to call a matching pair. They have to give you a value for x and a value for y in each question, because step 2, we need to find out the value of k. Now in this case with the table, the matching pair is this column here, because it's basically saying that when x is 10, y is 0.5, or vice versa. So step 2, we need to find the value of k. I'm going to substitute in my matching pair, so obviously be careful that you check which one is x and which one is y. I've got 0.5 is equal to k over 10. Do you see how now I've got an equation where the only letter that I don't know is k? So think about just algebra. How can I solve this? To get k on its own, I just need to multiply across by 10. So obviously 0.5 times 10 would just be 5. So for this particular proportion relationship, this particular question, the value of k is 5. Now what I like to do is then rewrite my equation, my formula, obviously now knowing k is 5. So k is 5, so 5 over x, so y is equal to 5 over x. Step 3 is then to actually answer the question. So in this case, that was to complete the table. And for this one, I've actually therefore got two steps, haven't I? I need to work out the missing x and then also the missing y. So let's work out x first. We want to know what is x when y is 1. So if I have this formula, I can substitute in y is 1 is equal to 5 over x. And now I just need to solve it. Now the only thing to really be careful of here is not really to do with proportion as such, it's more so to do with algebra and correctly rearranging the equation. You might think I just need to divide by 5. Well, you can do that, you get 1/5, and then this side you'd get 1 over x. It's still in a fraction. We haven't got rid of the fraction by dividing by 5, have we? We still have the fraction. So just be careful, this is particularly for inverse proportion, and when you're trying to find out the x value, that's not necessarily how I'd go about rearranging it. You can actually move the letter that you want to solve for. So when I've got a fraction, the only way to really get rid of the fraction is to cancel out the denominator, multiply by the denominator, which is x. If I multiply both sides by x, I get, obviously 1 times x is x. And now this is no longer a fraction. So I've got x is 5. So just be really careful there with how to rearrange this fraction. So this one is 5. Now, obviously, then separately to that, I can come back and say, right, I now know that x is 25. What is y? So the same formula, y is equal to 5 over x, but I now know that x is 25. I don't even need to rearrange that. I can just simplify it basically, isn't it? So I'd get 1/5 or 0.2 if you want to have it as a decimal. 0.2. Now I've completed the table. So hopefully if you did see the previous video, you'll know that it's exactly the same 3 steps. We just had to change the initial formula that we were using. Okay, so we've looked at one that has a table format. This is a different format where it's just all worded. So we've got 3 sentences here, which actually, luckily, match up with the 3 steps. So we've got y is inversely proportional to x. Again, step 1. What is my formula? Y is equal to k over x. Okay, then I need to use my matching pair. So they've said when y is 3, x is 12. So that's step 2. I need to use the matching pair of values so that I can work out what k is for this particular relationship. So 3 is y, k over 12. Let's solve this to find k. Find the value of k, so just obviously multiply by 12. That gives me 36 for k. Do you see how this one is a different value of k because it's a different proportion relationship, it's a different question. So therefore, let me rewrite my formula out, 36 instead of the k. So y is equal to 36 over x. That is the relationship. And then finally, step 3, I can actually answer the question. What is it asking me? Find the value of x when y is 2. So substitute in 2 for y equals 36 over x. And we're in this scenario again. You can see I had to be really careful with how I rearrange it. If you have inverse proportion and you are trying to find out the value of x, trying to solve for x, you're going to want to multiply by x, as we saw in the previous question. So if I multiply by x, I get 2x is equal to 36. And because it's 2x, I do now have another step because I want to just work out what x is. So divide by 2, x is 18. So the answer to this one is 18. So we've just seen some easier examples. We're now going to make it a little bit more complicated because it's no longer just y and x. We're now going to add in this case, x cubed. So y is inversely proportional to x cubed. So we've still got the same format in terms of the 3 sentences, so the 3 steps. Step 1, y is equal to k. No longer just over x, it's now x cubed. Whatever is here, that's what you're going to substitute into that formula. So not just x, x cubed. Step 2, use the matching pair of values to find out the value of k. So when y is 2, x is 5, and again remember we're now going to cube the 5. It's not just 5, it is 5 cubed. So 5 cubed is 125, so we've got k over 125. And obviously then just solve it as we did before. Let's bring this up here. If I multiply by 125, I get 250 for k. So therefore, my formula is y is equal to 250 over x cubed. Now for step 3, I can actually answer the question. What have they asked me to work out? Find the value of y when x is 10. So let's substitute in x being 10. Y is equal to 250 over 10 cubed. Okay, that gives me 250 over 1,000. Obviously, if it's a calculator question, you can just type it straight in as it is. But that would simplify to 1/4. So y is 1/4 or 0.25 as a decimal. So that one didn't actually need any rearranging because we already had y as the subject. So it's a little bit easier. Okay, a very similar one again, but now we're working with the square root of x. So y is inversely proportional to the square root of x. We're going to write down y is equal to k over root x. We're then going to substitute in the 2 values, so 30 for y, and then 9 for x, but I am going to square root that 9, so that gives me 30 is equal to k over 3. And then if I rearrange that, I get 90 for k. So rewrite your formula. Now with the value of k being 90, y is equal to 90 over root x. And then actually answer the question. So find the value of x when y is 18. So we've got 18 is equal to 90 over root x. Same scenario again, I'm going to have to move the root x. So multiply across by root x to get rid of the fraction. I can then divide by 18, so just root x is left on the left. 90 divided by 18 gives me 5, and then obviously now I do want to have x, don't I? I don't want root x. So if you square both sides, we get x is 25. And there's my answer. So hopefully you can see the pattern now. It's very, very similar the whole way through. So now we have a very similar question, but it's actually got a real world scenario to it. So the age in years, y, of a car is inversely proportional to the resale value in pounds. And they've told us to use V to represent that. An 8-year-old car is worth £3,000. How old is a car that is worth £2,000? So hopefully you can pick out that we've got the same exact 3 sentences here. It's just a little bit different because now we've got all of these extra words. So I'm going to start off by creating my formula. In this case, I am going to use the letters they've given me, so Y and V, and we give it in the exact same order that they've told us. So Y first equals to K over V. That's our inverse proportion relationship. Now, they've given us a matching pair of values, 8 years, £3,000. So substitute those in, 8 for the years and 3,000 for the value. We need to obviously find K. So multiply 8 by 3,000, we should get 24,000. So if I rewrite my proportion relationship, I've got Y is equal to 24,000 over V. And then step 3, answer the question. How old, so in terms of years, is a car that is worth £2,000? So they've given us the value for V, haven't they? We want to find out what Y is. So 24,000 divided by 2,000, and that should give you 12, which would be therefore 12 years in this context. 12 years. So exactly the same 3 steps, I just had to kind of pick out the information from the context, from the scenario. Okay, I have 2 questions to finish with. These are now what I would call double proportion, so we're using both inverse proportion and direct proportion in the same question. So think of those 3 steps we've been repeating, and we're just going to have to do each of those 3 steps twice. So you can see here we've been given 2 proportion relationships. Y is directly proportional to X, and then X is inversely proportional to Z. Then we've been given 2 lots of matching pairs, and obviously a question. So step 1, write down the formula, but in this case there are 2. You could do one at a time, or you can do them both at the same time, that's fine. So Y is directly proportional to X, remember that that is K multiplied by X. And then if I write the second one here, X is inversely proportional to Z, so K over Z. And you see how I've put the letters X and Z in the order that I saw them written in the question? Then we've got obviously our matching pairs. We're going to have to use the matching pairs for each relationship to find out the value of K. Now technically, because these are 2 separate proportion relationships, obviously the values of K are not the same. Now if you wanted to be really mathematical about it, we wouldn't use K for both, because that would insinuate that it's the same value when it's not. So you can use C if you like, but I don't think they're going to penalise you for it. So just to save confusion, I'm going to use K. So find K. So the first one we've got when Y is 12, X is 24. So that's obviously for my first relationship. So 12 for Y equals K multiplied by 20. So we would write that as 20K, wouldn't we? Solve this to find K for the first relationship. So if I do 12 divided by 20, I get 3/5, or obviously you could use 0.6 as a decimal if you like. And then if I rewrite that relationship, that formula, it's Y is equal to 3/5 X. Same for the second one. We've got when X is 7, Z is 2. So X is 7, and then Z is 2. Solve this for K, multiply by 2, we get 14. Rewrite that formula. X is equal to 14 over Z. So I've done the first 2 steps without even really looking at what the question was. Step 3 is obviously answer the question. What is the value of Y when Z is 6? Now this is how the 2 relationships, the 2 equations link. What is the value of Y, which is in this equation, when Z is 6, which is in this equation? Do you see how Y and Z are not in the same equation, which is why we need both? The link between the 2 equations is that they both have X. So what I'm going to do is substitute in 6 to the Z, because that's the only place I can put it, isn't it? it will tell me what x is, and then if I take the x value and put it into the second relationship, into the other equation, I can work out what y is. So first of all, x is equal to 14 over 6. Okay, that I guess only really simplifies, isn't it? 7 over 3. It's a decimal. And then substitute that into my other relationship, which is y is equal to 3/5 multiplied by x, but now I've just been told that x is 7/3, so you see how I could just work that out. I get 7/5. You can substitute the whole of this equation into that one to make the equation just y and z, and then substitute in 6 if you like, or you can do it this way, substitute in 6 into 1, take that answer, sub the answer into the other one. It's up to you which makes more sense. Either way, you should get 7/5. Okay, this is basically exactly the same question. I just made it slightly more complicated because we've got some squares and some roots in there as well. So a is directly proportional to b squared, b is inversely proportional to root c, and the question is, what is the value of a when c is 81? So let's go through those 3 steps again. The formula for direct proportion is a is equal to k b squared. The formula for inverse proportion is b is equal to k over root c. We're going to use our matching pairs, so a is 24 when b is 4, and obviously square it. If I were to work that out, that would give me 16k is equal to 24. Divide by 16, I get 3/2, or 1.5. So that formula is actually a is equal to 3/2 b squared. Same with the other formula, we've got b is 3 when c is 225. If you square root 225, you should get 15, so k over 15, and then just multiply across, so I get 45 for this value of k. Therefore, my equation is b is equal to 45 over root c. Step 3 actually answers the question. So I've been told that c is 81. Okay, that means I need to substitute it into the second one. So b is equal to 45 over root 81. Therefore, that gives me 5. And now, if I take b, I can put it into the first relationship to find out what a is. So 3/2 multiplied by b squared, which is 5 squared. As a fraction for a, that gives me 75/2, or as a decimal, 37.5. So that is everything you need to know for the basics on direct proportion and inverse proportion. As I said, the original video for direct proportion will be linked in the description. Otherwise, thanks for watching this video. If you found it helpful, make sure to like and subscribe, and leave down below any questions or comments that you might have.